Hello and welcome to this last session on the ITM Data Exchange, where we discuss the preliminary data model we've created so far. So I want to highlight some of the choices we've made, and please go and have a look at the graph data model session, which is more generic explanation of the graph data model we use, and some of the technologies and techniques we used for creating the preliminary model are explained more in depth in that presentation. So when we went looking at the various data we've got throughout the process, but also looking at the documentation of ITM processes, we realized that ITM is essentially about events. So every ITM action, which is in an inspection, a test, or a maintenance activity, has a time and place, which basically means it's all about events. And specifically for the research that we tried to conduct, the key elements of the ITM are time aspects. So the intervals and the due dates. So did we meet the due dates and did we meet intervals of specific tests, etc., etc. So it's all event based. So we decided to go for the SEM model, and I'll explain that a bit later on. We start with an ITM site activity, which is basically, it's an event and it's a container of ITM activity. So the site activity is you're going to do a inspection, a test, or a maintenance round on a specific site. And that's what we found in the data, and that's what we found in how the inspections are recorded normally as well. People take a full building or a full site, so that's why we call it site activity. They contain ITM activities, and we're going to explain that a bit later on, what we consider ITM activities. And the site activity points to a location, a report, and actors. And we base that on the simple event model. So the simple event model looks like this, where you can see the central, there's a core, and everything has an actor, a place, and a time. So an event is built up out of these elements. And if you think about ITM activities, it's more or less like that. You have either a building owner, inspector, or an HJ, which are the actors. Or you have timestamps. When was something installed? When did the inspection take place? When was the due date, etc., etc. And were there intervals? And this model basically can support us for that. So in the graph technology video, I explained that you can reuse models and make it easy to go over various data sets by using the same models and then do all sorts of analysis. And that's why we chosen for the simple event model, because it's really easy to convert data into this model. And as you can see on the top left, there is simple event model can have events pointing to events. So events can have sub-events. So you can have one event describing the whole thing, which is the site activity, and then sub-event describing the actual activity. So a site activity is the container for all the ITM activities, and the ITM activity by itself is again an event. And we are fully aware that some of the data out there just takes, well, on a certain date, somebody did an inspection, and none of the specific activities, testing pumps, etc., have their own date times. Some of the data has, so this allows you to do that, and what you can basically say, well, if we don't have this data, we can infer that from the site activity. That's no problem. The ITM activity is basically a base class, and I explained that in the graph model. So where you can have layers of classes, where on a higher level you can have a higher abstraction of information, and we try to document that in the document you've received as well, the PDF that's been circulated before the workshop. So it's a base class for item specific activities. So you have another class for fire pump inspections or panel activities, and detectors activities for smoke detectors, where you will find the certain properties for these specific activities. The ITM activity basically has the generic properties. The item, it points to a certain item, a time, and a place. So what we've done, which is different from the data we've got, but the data we did support it somehow, say, okay, we're going to describe the ITM item specifically in a separate mini graph. So there we're going to store the generic properties of an item. So it's the make, the model, the serial scan, the install date, and some of these more static things about a specific item. So a fire pump is stationary in a building and remains there, and all the ITM activities talk about the same pump. So the interesting thing you can do, if within your data you can actually pinpoint specific pumps, you can have a timeline. So in the demo I'm going to do of what we've done with the data, we actually got a bit of data where serial numbers were in place. So we were able to say, okay, we can track a certain timeline of an activity. And the other thing is, what we wanted to do is, by separating the items from the ITM activities, was that we can align it to building models. And you can find some notes on that in the document as well, that we thought it was important to, as soon as possible, be able to say, okay, this is actually a building system. Every ITM item is more or less a building system, so we can align that to that. If you only record the activity and you're not pointing to the items, you cannot claim that an activity is actually a building system. This way we were allowed to say, okay, we can drag this specific item out of a activity and make a separate item out of that. And from the demo of what we've done with the data, it's pretty clear what you can do with that. So then it becomes obvious. So then we have item-specific ITM activities. So where we have properties which are related to the specific item type. So we talk about flow rates, water levels, etc., etc. So various items in a fire protection system have various bits and pieces that need to be checked or tested or maintained. These are all properties on the specific items. And properties are derived from generic properties. So you can have a test property, an inspection property, or a maintenance property. And we can find them back in the documentation of the NFPA 25 or the 72, where it's specifically stated you need to check this or you need to inspect that. The idea of using this is that by the presence, and that's the inference we talked about in the graph data model, by the presence of certain properties, you can say this activity was actually a test, a maintenance, or an inspection. And the idea is obviously, and that's the beauty of RDF, that we've seen in the data that sometimes the test and the inspection was done on the same run. So a specific ITM activity will be both a ITM inspection as a test. And that's what the RDF data model allows without doing really ugly things. What we've done is to make sure that most of the property values are data cube ready. And the idea behind that, and we've documented as well, data cube allows you to do statistical analysis on large data sets, and that's what we in the end wanted. So by making sure that the model by itself actually embraces the idea of data cube, you can really easily generate statistics out of data once it's converted to the graph model. And the other part we've looked at is, can we align these properties to SSNs, semantic sensor networks? So although it's not completely out of scope, it did seem to work pretty well. So we now have sensor networks that allow integration of remote sensing and testing. So by using this standard to describe remote sensors, it would be able in future releases of a data model to actually say, oh, we can extract this data directly, or we can tell something about the sensor that got this piece of information. Where was it? How was it connected, etc. It's not completely relevant. For us, it was more a try and also an idea to have this extensibility demo. It's like, hey, this is something you could do, but it's not completely relevant for the data model as it is right now. So how does it look, the preliminary data model? And this is a very simple sketch out of it, and we're going to go browse through it in the workshop. So on the left hand side you see the ITM activity, which has a location, which has some actors, and which has a report in the end. And on the other hand, you have the ITM activities, which end up with properties, deficiency lists, etc., etc. It's important to recognize that both locations and actors are actually not present in the data we created for the demo, because the concerns of privacy and commercial viability, etc., etc., we decided to leave that out completely. But the model itself is able to actually do that. So if you want to use this model and this type of analysis internally on your own data after it's being converted to the generic model, you could still include your own sites and locations, etc., etc. One thing we had a slight internal discussion about, okay, well, states could be interesting, to just put a state on there for the data, that you could see if there is a statewide differences between the way ITM is executed, etc., etc. But since there was not a lot of data we've got from a lot of different places, we decided to leave it all out for this specific reason. So that we could have put it in, but privacy concerns, etc., we completely left it out. And if this is sort of the diagram overview, there's a website which we're going to scroll a bit through on the demo or in the workshop as well, where the data model is completely outlined. As I explained, this is a preliminary data model, so there's still a lot of testing properties need to be moved around and to make it more in line with what you actually find in the 25, but that's probably an easy task as far as we've come right now. We were already able to extract a lot of these properties out of the various data sets we got, obviously with some help of the people who provided it. So this was a really quick and broad overview of how the data model is constructed, what we've done, the choices we've made, and during the workshop we will have some time to discuss that, and afterwards, obviously through email, we can have some discussions about this as well. Thank you for your attention, and I hope to meet you all at the workshop.